So we're asked to find for which values of t the following parametric curve is concave up. So remember, that means the second derivative has to be positive. So first of all, let's compute the first derivative. dy dx, that's dy dt over dx dt. So dy dt, that's 12 t to the fifth, and dx dt, that's 3t squared. Okay, and it looks like we can simplify something. Provided t is non-zero, then we have 4t cubed. Now the second derivative. So that's the derivative of the first derivative. So the derivative of the function dy dx with respect to dx. I'm going to use the same formula. This allows me to compute the derivative of a function with respect to x. It tells me that I need to put the function here. So the numerator is the derivative of the function with respect to t. Here the function is dy dx, so the numerator will be the derivative of dy dx with respect to t. So see the resemblance. And then divided by dx dt, well, that's not involving the variable, so it's just dx dt. So that's the formula. This is just a way to remember it and interpret it. So dy dx is 4t cubed. So I need to do the derivative of 4t cubed with respect to t, and then divided by dx dt, which is 3t squared. And this derivative is 12t squared. So now again, it looks like I can simplify provided t is non-zero. This is equal to 4. So for which values of t is this positive? Well, for all values of t, because that's 4. That's always positive. So here, but provided this t is non-zero, that's a subtlety in the sense that then this curve is not regular at that point. But for our purposes, it doesn't really matter. So this curve is concave up for all values of t. So let's say between negative infinity to infinity. Now I claim that we can be convinced of this in a geometric way because we actually know what this curve represents. We can find a Cartesian equation and we know what that is. So let's do that. I mean, the exercise is solved, it's just to check. So in general, you would want to solve one of the equations for t and then put into the other one, unless you can figure out some relations, some special relations. So here we have t to the sixth, that's t cubed squared. But t cubed is x. So t to the sixth is x squared. Therefore, I can put in here and obtain y equals 2x squared plus 1. And I know that that's a parabola. So, when x is 0, the vertex is 1. And it's a parabola that looks like this. And this is concave up it's always concave up in its all range. So that's consistent with what we found.